everyone, welcome back to my channel. I hope you are doing well. In today's lecture, we are going to discuss one of the most important and fundamental concepts of organic chemistry, that is hybridization. This topic is extremely important because it helps us understand the shape of molecules, bond angles, and how atoms actually form chemical bonds. Many students get confused about why carbon forms four bonds, even though its electronic configuration suggests something different. In this lecture, we will clear that confusion step by step in a simple and logical way. So, let's start. First of all, let us understand why hybridization is needed. According to valence bond theory, no half-filled orbitals take part in bond formation. A covalent bond is formed by the overlapping of half-filled atomic orbital. Now let us take the example of carbon. Carbon has atomic number 6. Its ground state electronic configuration is 1s2, 2s2, 2p2. In the second shell, carbon has only 2 unpaired electrons. That means, according to theory, carbon should form only 2 bonds. But experimentally, we know that carbon forms 4 bonds, for example, in methane. So, now we will understand how this is possible. To solve this problem, we consider the excited state of carbon. In the excited state, one electron from the 2s orbital jumps to the empty 2p orbital. And then it is jump to the empty 2p orbital. Now the configuration becomes 1s2, 2s1, 2p3. Now carbon has 4 unpaired electrons, so it can form 4 bonds, but there is still one more problem. One orbital is s and 3 orbitals are p. They have different shapes and different energies, so the bonds formed should not be identical. However, in methane, all 4 carbon-hydrogen bonds are identical. The bond angles are 109.5 degree and the shape of molecule is tetrahedral. This bond angle is 10.5 degree and the shape is tetrahedral. To explain this, scientists introduced the concept of hybridization. To explain fully the shape and geometry of such molecules, Pauling and Slater introduced a new concept that is called hybridization. Now we will see the definition of hybridization. Hybridization is a process in which atomic orbitals that have different energy and different shape mixed together and forming a new orbitals that have equal energy and equal shapes. These new orbitals that are formed are hybrid orbitals. During the process of hybridization, different atomic orbitals are mixed in different ways, such as 2s orbitals or 2p orbitals, or the mixing of 1s orbital with a p orbital as well as s orbital with d orbital. There are 3 types of hybridization: sp3, sp2 and sp. So today we understood why hybridization is necessary. We discussed the ground state and excited state of carbon, and we learned how mixing of atomic orbitals form new hybrid orbitals with equal energy and equal shape. We also understood the hybridization explains the tetrahedral shape of methane and why all 4 bonds are identical. So in the next lecture, we will study the types of hybridization including sp, sp2 and sp3 in detail with examples and shapes. Make sure you watch the next video to fully understand this important concept of organic chemistry. Thanks guys for watching my video.